Hello, geometry students. We're ready to do another notes. I'm so glad that you're participating. Really proud of you for taking charge of your learning and moving forward in geometry despite these difficult circumstances. We are going to proceed with notes 1.5. So go ahead at the top of your notes and write a 1.5. The title is Measuring and Constructing Angles. So measuring and constructing angles. And I'm just going to be lazy and draw a symbol for angle instead of the word. That's totally legit. All right, so today is actually kind of important because we're going to talk about a lot of vocabulary words that we are going to use in the context of measuring and constructing and working with angles. And then I'm going to do, after the vocabulary words, 4 examples with you guys. Many of these you've heard before, but I just kind of want to make sure that we are on the same page. So obviously, it would make sense for our first vocabulary word to be the word angle. And in all of these cases, I'm going to read you the definition. Don't worry about writing that part down. The only thing I want you guys to do is to draw the picture of the angle. So, for the angle, an angle is 2 non-collinear rays that have a common endpoint. Non-collinear obviously means not on the same line, and the common endpoint is the point where the 2 rays meet. So that is a picture of an angle, and that's the only part you have to do. All right, the next word is vertex. And again, I'll read the description. You don't need to write that down. Just draw whatever I'm diagramming on the board. The vertex is the common endpoint of an angle. So, for example, we can just draw an arrow to that picture there. That would be the vertex of our angle. That is a word we're going to use quite a bit. Now what I want to do is tell you the 4 types of angles that are going to be used in this section of the book, and also several other sections. The first one is a right angle. Now we've already talked about this at the very beginning of class, but you should know it's an angle with a degree measure of 90 degrees. So we'll draw our 2 rays, but right where the vertex is, we're going to put a box to indicate that that's a 90-degree angle. The next one I want to write down is acute. An acute angle is an angle with a degree measure less than 90 degrees. So let's draw that angle here. Can you guess what the next one is? I think many of you can, because you've learned about angles before. We've talked about right, we've talked about acute. Right is exactly 90 degrees, acute is less than 90 degrees. What do you think the next one is, and what is its definition? I hope you said obtuse. An obtuse angle is an angle with a degree measure greater than 90 degrees. So we might draw it something like this. And it could be, let's just label this as, I don't know, 160 degrees. Let's label our acute one as 20. Doesn't have to be exact. We're just trying to convey that they're not equal to 90. The acute is less than 90 degrees, and the obtuse is more than 90 degrees. Now there's one other type of angle that they use on the homework. It's called a straight angle. It sounds really fancy. It's basically just a line. Another way of referring to it is opposite rays. In math, there are many times where you have more than one correct way to refer to the same thing. The formal definition sounds very confusing, but like I said, it's just a line. Opposite rays are 2 rays, BA and BC, such that B is between A and C. Let's just draw a picture of that because that'll make it a little bit easier. We've got 2 rays, BA and BC, and they are opposite each other, so they form a line. And in this case, you can see that that is going to work out to be exactly 180 degrees. That's an important fact to know. Okay, now we've got a few more words, and then, like I said, 4 examples. Let's write down the word interior. The interior of an angle is a point that does not lie on the angle itself and is inside the rays of an angle. So like if you're an interior designer, right, you design the inside of a house. So we can draw an angle here with the point on the inside. Can you guess what the next vocab word is going to be? Not interior, but exterior. So if we're talking about an exterior angle, it's a point that does not lie on the angle itself and is outside the rays. So So let's just put a little dot here and show that dot on the exterior of the angle. Okay, let's talk about a side. A side of an angle is just the rays of the angle. So for example, in this angle right here, this would be a side, and this ray would also be a side. And in the interest of time, I'm just gonna draw arrows to the picture we already drew. You guys are doing great. We have 4 more words. Ray, we actually already kind of talked about, I think, but a ray is part of a line. So we'll just draw a picture of that there. It has an arrow on one end and the point on the other. Congruent angles, this is important. Congruent angles. Now, I prefer not to write out the whole word congruent. We have a symbol for congruent if you want. It's an equal sign with a sideways S on top of it. So congruent angles are angles that have the same measure. So for example, it could be a 30-degree angle and another 30-degree angle. They don't actually have to be pointing the same way like I do here. I'm just trying to save space, but they have to be the same measure. Okay, 2 more vocab words and we'll do our for example. Angle bisector. Now, bisector is a word we are going to use quite a bit this year. Does anybody know what bisector means? Bisector means to cut in half. So, if I bisected a ruler, how many pieces would I have, and how would their lengths compare? I'd have 2 6-inch pieces that would be exactly the same length if I cut a ruler exactly in half, because a ruler is 12 inches. So that's an important concept to understand. So an angle bisector would bisect an angle. It's a ray that divides an angle into 2 congruent angles. So let's say, for example, you had a right angle and you bisected it. We could show the fact that it's bisected by putting little arcs here. That's our way of saying that those 2 angles are the same measure. And each of those separate angles would be 45 degrees. If we bisected a right angle, each of the angles that we got when we did that would be 45 degrees. Okay, and then the last one is degree. A degree, I'm just going to read this to you, is a unit of measure used in measuring angles and arcs. So we've been using that word for quite some time. In fact, I think you've probably been using it for years, but that's just the formal definition of it. All right, so that is the vocabulary part of your notes. Now what I wanted to do is 4 examples for you that are similar to ones that you will see in the homework, and also that use the vocabulary words we just talked about. And if I went over anything too fast, and you need to, again, remember you can pause the video and write the notes down again if you need to. Also, put like a question mark next to that part of the notes and then ask me about it during the Zoom session. All right, so let's do example 1 here. Example 1 is going to say, find the measure of angle BAD. Now notice when I said measure, I was writing a little m. When you have a little m in front of the angle sign, that is a way of saying measure. Now I'm going to draw a picture of that angle. B, A, and D. Find the measure of angle BAD. Now I'm going to show a ray going through that angle. Now they have not told us that this ray bisects the angle, so we don't have anything that tells us that that is true, but we are seeing that the 2 angles formed are 35 degrees and 22. Now the angle addition postulate tells us if we have 2 angles that are right next to each other, the formal word is adjacent to each other, that we can find the measure of the bigger angle that they form by just adding those 2 degrees together. So if we trace out angle BAD, if we go from B to A to D, we can see it's this whole angle right here. So to get the measure of that angle, we're going to add the 2 smaller ones, 35 plus 22, and get 57. So the answer would be 57 degrees. That would be the measure of angle BAD. Okay, let's do example 2. And again, I'm just doing 4 examples on the notes because I know we had a lot of vocabulary words. So we're going to draw a picture here of a line with an angle jutting out from it. And I'm going to label the left hand angle 2x plus 20 and the right one x plus 10. Now I would like you to think for a minute about how much those two angles have to add up to and what your equation might be to solve for that. And again, this is example 2. And if we wanted to solve for x, the directions here say find x. I'd like you to think about what do the two angles have to add up to, and what would the equation be that I would use to solve for x. Okay, now I know I didn't give you much time. If you want to pause and think about it some more, please do. These two angles form a line, so we know that they have to add up to 180 degrees. Because this angle plus this one equals 180, I can write 2x plus 20 plus x plus 10 equals 180. Now we're going to use some algebra skills. Some of you are more comfortable with this than others, so I'm going to tell you each step. We first combine like terms. 2x plus 1 more x is 3x, and 20 plus 10 is 30. What would I do next? I want to use opposite operations. The opposite of adding 30 is subtracting 30. So 3x equals 150. And then the opposite of multiplying by 3 is dividing by 3. So x is 50. That is exactly how we would do example number 2. All right, you guys are doing great. Now we're going to look at example 3. I'm going to label this problem here with N, J, and M. And then I'm going to have 2 rays in the interior of that angle with points L and K. Take a minute if you can, zoom in on that, and I'm going to put a 30 here and a 35 there. And then I'm also going to write some instructions at the top in just a moment here. So try to get that part of the angle drawn right here. The instructions are, it says the measure of angle JNM equals 110 degrees. Find the measure of angle JNK. And again, I really appreciate all the work you guys are going to write this down, because normally I will give you notes that you just kind of fill in. But we are doing the best we can under these circumstances. So let's figure out what this first piece of information is telling us. It says the measure of JNM is 110 degrees. Let's draw that out. J to N to M. So they're saying that this whole big angle here is 110 degrees. And they want us to find the measure of J and K. Let's trace that out. So from J to N to K is what we're trying to find. Let's just call that X. And by the way, if you feel like taking notes with colored pencils, that can make it a little bit easier in geometry because we have so many things that we're diagramming. All right, that's the basic figure. Maybe zoom in on this if you need to. But see if you can come up with what equation we would need to set up to solve this problem. Okay, so here's the deal. These 3 angles add up to 110. So I can say 30 plus 35 plus x equals 110. Once you have the figure actually labeled, doing the math is not as difficult. When we take 30 plus 35, we get 65. So we're combining like terms, and then again, opposite operations. The opposite of adding 65 is subtracting it, and then x becomes 45 degrees. So when they were asking us to find the measure of that angle, the answer is 45 degrees. Okay, I have one last example for you guys. That was example 3. Our last example is going to be example number 4. And then you will be done with your 1.5 notes. So example number 4 has a fairly complicated diagram in it. So we're going to take our time labeling it. First, I have a straight line with dots, or points I should say, for A, B, and C. And then I'm going to have rays shooting up from that labeled with points D, E, and F. And again, don't worry if this is perfect or exactly to scale. We'll be able to set up the equation as long as you have the basics of the figure. Now I'm going to read the directions. Please don't feel like you need to write them down because I'm going to help you label this. You can also always rewind and forward this video as you need to. In the figure at right, that would be this figure right here, BA and BC are opposite rays. So BA and BC are opposite rays. That's telling us that this is a straight line, which also is telling us that all of this adds up to 180 degrees. Okay, and then it says BD bisects EBC. So ray D bisects angle EBC. Because this ray right here bisects angle EBC, we can put little arcs here to remind ourselves that those two angles would have to be the same, because remember, when a ray bisects an angle, it cuts it into two congruent separate angles, two congruent halves. All right, so then we get some more information. The measure of EBD, that would be this angle right here, is 4x plus 16. So I'm going to label that on my diagram. The measure of EBD is 4x plus 16. And again, this is example 4. Also, the measure of DBC is 6x plus 4. So I'm labeling that here. And now it says find the measure of EBD. And this is a little bit tricky. EBD is this green angle right here. So we kind of have to ask ourselves, what do we know? And they've given us actually more information than we need, partly maybe to make the problem a little more confusing. We don't actually end up needing to use the information that this whole set of angles adds up to 180 degrees because we're only talking about this part of the picture. So what do I know about these two angles here? Think about that for a moment and think about, given what we know, what equation should we use to solve for x? What do we know about this angle and this angle, angle EBD and DBC, and how can we set up an equation to solve for x? Okay, so hopefully you know that they are the same size, they are congruent angles. So because of that, their measures are the same. So I know that 4x plus 16 has to be equal to 6x plus 4. And this is, again, where we're going to use our algebra skills. We want to combine like terms. So I am going to subtract 4x from both sides. I have 16 equals 2x plus 4. Now again, using opposite operations, the opposite of adding 4 is subtracting 4. So now I have 12 equals 2x. And the opposite of multiplying by 2 is dividing by 2. So x is 6. Now some of you are thinking, thank goodness the notes are over. Guess what? We're not done. Remember, in geometry, a lot of times even after you find x, you still have more work to go. So this is correct that x is 6, but we haven't actually answered the question because the question said, find the measure of angle EBD. So I would like you to look at your paper and see if x is 6, how could I find the measure of angle EBD? All right, let's look at our picture here. EBD is the angle that's marked as 4x plus 16. So let's write that this equals 4x plus 16. Now, because we know that x is 6, we can plug that in where we see the x. So we can take 4 times 6 plus 16. 4 times 6 is 24. And then when I add 24 to 16, I get 40. So our final answer is 40 degrees. All right, guys, you've done a fantastic job. I'm super proud of you. Can't wait to see you in Zoom. Bye.